Copper, in the form of raw material, is delivered to the foundry. After preparation, copper is charged into a natural gas shaft furnace for melting. The molten copper is disoxidized and transferred to an intermediate holding furnace, through which it is then fed into the cooling molds for solidification. The fully automated casting process is performed vertically and continuously into a round semi-finished product called billet. The copper billets are cut to length, weighed, barcoded, and stored in the yard after undergoing the necessary quality control inspections. Copper billets arrive at the tube plant from the foundry by truck, and are stored in a holding yard. The billets are conveyed to two preheating gas furnaces, and alternatingly transferred to an induction furnace, to homogenize the temperature to approximately 900 degrees Celsius. Upon reaching the final temperature, the billet is then transferred to a modern hydraulic 4,000-ton press, and extruded into an initial tube. The extrusion press is fully automated, with an exceptionally high productivity rate of 40 extrusions per hour. Equipped with fully automatic tool management system and oxide descaling capability, ensuring the high quality of the produced product. The tubes are extruded underwater to avoid oxidation and for quick cooling. Immediately after cooling, the tubes are bar-coded for full traceability. A 75-ton pulling force carriage drawbench operates in conjunction with the extrusion press. With an innovative inner gripping system, the tubes are drawn through a die and plug to reduce their dimensions. Two tubes are drawn simultaneously at a speed of 60 meters per minute, producing a length of approximately 60 meters. A double-carriage 25-ton shoemag drawing machine is incorporated in the main breakdown line, drawing the tube with circular jaws at a speed of approximately 90 meters per minute. Two cold pilger mills are utilized in the initial reduction stages. The mother tube is rolled onto an internal mandrel, with a high reduction ratio, transferring an initial length of 15 meters to 100 meters. A complex of state-of-the-art chain track drawing machines constitutes one of the highest productivity reduction assemblies worldwide. Encompasses 3 machines equipped with 2 chain tracks caterpillars to draw the tube through a die and plug. The first 2 machines are coupled in series, performing 2 reduction in sequence, with a pulling force of 18 tons and 10 tons respectively, and a final speed of 250 meters per minute. The produced length is then coiled in a basket, which is then conveyed to the third machine and distributed to the rest of the factory. A cascade drawing system, utilizing 2 shoemag drawing machines, draws the tube produced from the pilger mills, with 2 reductions in series, and coiling it into a basket. Subsequent multiple reduction occur at spinner blocks. The tube is drawn from basket to basket through a die and plug, using a spinning drum with consecutive reductions, until the final or semi-final tube dimensions are reached at speeds up to 1,500 meters per minute. Tube dimensions range from 4 to 30 mm OD and 0.25 mm to 3 mm wall thickness. The baskets are then automatically conveyed to finishing machines, to get their final form, straight length or coiled, or to internal grooving machines. Prior to grooving, the tube is annealed at a contemporary proficient induction furnace, at speeds up to 500 meters per minute. "12 highly efficient inner grooving machines installed. Grooving is performed by placing an internal tool, mandrel, inside the tube, and rolling it onto the mandrel, to form the inner surface. Over 100 different profiles are produced depending on their end application, evaporation condensation, ranging from 4 mm to 16 mm OD. LWC, level wound coils, are produced at 8 spoolers. Heat tube is drawn from the basket, at speeds up to 400 meters per minute. Eddy current tested, and coiled on a large drum. ECT or NDT, non-destructive testing, is executed with a stationary, through-type, coil and rotating probes, to detect and mark any possible detrimental defect on the tube. Coil weights vary from 85 kilograms up to 580 kilograms. Final annealing is performed at 3 roller hearth furnaces, 2 of which are equipped with an internal purging system, to super clean the tube of all drawing lubricant. Other finishing machines include straighters, where the tubes are straightened and cut in lengths up to 7 meters, in either hard or half-hard condition. Half-hard tube are initially induction annealed and drawn to the required state. Straight lengths are cleaned at a high capacity, completely closed degreasing units, to remove all chips and drawing lubricants. The unit operates under vacuum with 0 emissions, incorporating automatic detectors, as well as an automatic loading and unloading system. Tubes in straight lengths and PNC coils are heat treated in an inert atmosphere and tempered to various conditions, with specific settings for each tube and application. Tubes are coated with a protective PVC or polyethylene coating in various profiles and colors, depending on their application. tubes are insulated along their entire length with extruded high-quality polyethylene, suitably expanded, to form a foam with closed microcells. A layer of thin polyethylene coating is adhered to the insulation, providing the required protection. Pre-insulated tubes are then automatically coiled in various lengths and packaged according to customer requirements. Straight-length tubes are end-capped, or plugged in small clusters, or individually, and bundled at automated packaging stations. PNC coils are commonly packaged in shrink-wrap film, placed in carton boxes, and then stacked and wrapped on pallets automatically. LWC are packaged with or without carton spools, stacked and wrapped on wooden pallets, and then stored in a modern high-level pallet racking system. Foam insulations are produced in two forms, pipe and sheet. More than 15 million pipe foam meters and 2.8 million sheet foam square meters are annually produced. The produced foam pipes are cooled for approximately 20 meters before being coiled into baskets. The line is fully automated as per the control of extrusion parameters, gas feeding rate, and product's dimensional stability. The raw materials are fed through an automated gravimetric unit. The raw materials are extruded to a mother sheet form, which is expanded to its final sheet foam form through 4 heating ovens. The produced sheet foam can be laminated on one side, in different outer film embossing patterns. The final sheet foam products are then coiled in large rolls,